Welcome to Brain Vision.
Hello students, in this question we have a magnetic loop. So this is the magnetic circuit given which has a coil set up in here, and this has the core, this is the core part, and coil has n turns which is 95 turns, and the gap diameter, this is the gap diameter is equal to 2.4 millimeter, and the core length LK or LC will be equal to, or L is equal to 25 centimeter. The cross sectional area is 3.5 centimeter square. The current passing through this is equal to 1.4 amperes. So first we need to calculate the reluctance of the core and the gap. So reluctance is given by the equation 1 by mu 0 times A. That is the reluctance equation. So reluctance of the core will be equal to, this is I, right? I by mu 0 A. So I by mu 0 A, and reluctance of the gap will be equal to G by mu 0 A. So this is the equation for that, right? So let's calculate that. So RC will be equal to 1.4 by mu 0 is equal to, is given by the equation mu 0 is equal to 4 pi times 10 to the power minus 7 times 3.5 centimeter square. So you will get 226,319 ampere per Weber. So similarly R gap will be equal to G value, which is equal to 0.24 divided by 4 pi times 10 to the power minus 7 times 3.5. So you will get 17543 ampere per Weber. So that is the value. Now this is the first part. Now coming to the second part, we need to calculate the total flux. Flux is equal to N times I by R, Ni by R, that is the flux value. So the R value will be equal to R core plus R gap, right? That is the R value. So you will get the total R value will be equal to 243,862 when you add it. So you now get the flux. Let's calculate the flux will be N, which is 95 times 1.4 divided by 243,862. So you will get 0.000547 Weber. That is the flux. Now we can calculate the flux linkages, right? Flux linkages using the equation. Flux in linkages lambda is equal to flux times N. So that is equal to, again you can multiply this thing, 0.000547 times N is equal to 95. So that is equal to 0.0 is equal to, let's write it here, 0.05196 Weber turns. That is the flux linkages. Now we can calculate the coil inductance L will be equal to lambda by I. So that is equal to 0.05196 divided by 1.4. That is equal to 0.03711 Henries. So these are the values. We have found out everything. The coil inductance we have found out. The total flux we have found out here. So we have also found out the flux linkages of the coil, and we have found out the R values of core and the gap total R value. So this is a solution. I hope you find the solution useful. Thank you.